can see a web animation. Let me see. Now here is an interactive exercise which can be used to calculate the total capacitance. The total capacitance of the network will be calculated for you if you select. If you notice, we have chosen two capacitors in series, and each of the capacitive values is 30 nanofarad. If you connect two capacitors in series, each of them 30 nanofarad, what is the total capacitance? Well, remember, two capacitors in series, the total capacitance will be C1 C2 divided by C1 plus C2, which is 30 multiplied by 30 divided by 30 plus 30, and that will be 15 nanofarad. Well, this illustrates an important principle. If you connect two equal capacitors in parallel, the total capacitance will be half of one of them. So tell me, if two 10 microfarad capacitors are connected in series, what is the total capacitance? The total will be 5 microfarad. If 200 microfarad capacitors are connected in series, what will be the total capacitance? It will be 50 microfarad. If two equal capacitances are connected in series, the total capacitance will be half of one of them. Alright, tell me, if you connect 3 equal capacitors in series, what do you think will be the total capacitance? 3 in series. Well, that will be 1/3 of one of them. If you connect a 30, a 30 and a 30 in series, the total capacitance will be 1/3 of 30, that will be 10. We don't have that option here, but we have 5 series. Alright, tell me, if I have 5 of these, C1 equal to C2 equal to C3 equal to C4 equal to C5 is 30 nanofarad. If I connect 5 equal capacitors of 30 microfarad in series, what will be the total capacitance? It will be 1/5 of 30, and that will be 6 microfarad. Let's do that. You got 5 in series. Alright, let's connect 5 in series and see what happens. There you go. So we have 5 of them in series giving you 6 nanofarad. And what happens if you connect 2 of them in parallel? If I connect a 30 and a 30 in parallel, what will be the total capacitance? Well, a parallel network gives you a total capacitance, the sum of the capacitances. So 2 in parallel will give, let's see. So you can see how capacitors are connected in parallel. 2 capacitors in parallel and connected to, this represents a supply, a potential source of potential. So the total potential is 30 plus 30, that is 60. How about 5 in parallel? If I connect 5 of these capacitors in parallel, how will it look? 5 in parallel. There you are. So 5 capacitors, you notice that the positive of each of them is connected together, and the negative of each are connected together, and the battery is connected between them. That means the potential difference across each of them is now the same, and the charge is divided. When the total charge come here, it will get divided into Q1, Q2, Q3, Q4, Q5, so that the total charge Q equal to Q1 plus Q2 plus Q3 plus Q4 plus Q5. Alright, let's now look at a series parallel connection. Now, how is that going to look? There I have two capacitors in series, and that combination is connected to a third one. So you got to say this series connection is connected in parallel to a C3. Can you tell me what is the total capacitance here? I know you will read it from here, 45 nanofarad, but how do you get it? First of all, look at this series. Two capacitors, 30 and 30 connected in series will give me half of 30, 15. So these two in series will produce a 15. That means it is now a 15 connected parallel to a 30. A 15 and a 30 in parallel will give you the sum of the two as the total capacitance. So 15 plus 30 is 45. Okay. Is there anything else we need? Let's look at this one now. Alright, can you tell me what this will be now? We have calculated this combination, is that right? What is the total capacitance of this combination? Will be 45 nanocoulomb. Now you have a 30, a 45 and a 30 in series. You need to calculate it using the formula 1 over C equal to 1 over C1 plus 1 over C2 plus 1 over C3, and see whether you get this. If the total capacitance is C, then 1 over C will be 1 over 30 plus 1 over 45 plus 1 over 30. Now check if you get this value, 11.25 nanofarad. But this is a good exercise to understand the meaning of series and parallel connections. Let's now do a problem. A 10 microfarad capacitor is connected in parallel with a 20 microfarad capacitor, and the system is connected across a 6-volt battery. What is the equivalent capacitance of the combination? B, what is the potential difference across the capacitor? And C, find the charge on each capacitor. Well, you got to start by drawing a diagram. How do we connect a 20 microfarad, a 10 microfarad and a 20 microfarad in parallel, and then the system across a 6-volt battery? Do you want to try it on your own? Well, that'll be nice. There you are. A 10 microfarad and a 20 microfarad are connected between 2 points A and B. That is what a parallel connection means. And the battery is connected between A and B. Now you must understand, because the two capacitors are connected in parallel and across a 6-volt battery, each capacitor has a potential difference of 6 volt across its place. So the potential difference for the first capacitor is 6 volt. The potential difference across the second capacitor also 6 volts. When you connect capacitors in parallel, each will have the same potential difference across its ends, which is equal to the total potential provided by the battery. Okay, now we got C1 10 microfarad, C2 is 20 microfarad, and the total potential V equal to 6 volt. The total capacitance will be C equal to C1 plus C2. When capacitors are in parallel, the total capacitance is C equal to C1 plus C2. That will be 30 microfarad. Well, what's the next one? What is the potential difference across each capacitor? Now, how do you find the potential difference across each capacitor? That must be very difficult, is that right? Well, when capacitors are in parallel, they have the same potential difference equal to the total potential. The total potential is 6 volt. That means the potential difference across each capacitor is the same. when capacitors are in parallel, they all have the same potential difference across them, which is the same as the total potential difference, which is V equal to 6 volt. So potential difference across the first capacitor is 6 volt, V1 equal to 6 volt. The potential difference across the second capacitor, V2, also equal to 6 volt. Now, C, we need to find the charge on each capacitor. Well, we know the capacitance, we know the potential difference. Therefore, Q equal to CV, Q1 equal to C1 V1. And that will be 10 microfarad times 6 volt. That will be 60 microcoulomb. And Q2 equal to C2 V2. The charge on the second capacitor will be C2 times V2, 20 microfarad times 6 volt. That will be 120 microcoulomb. Now tell me, if the charge on the first capacitor is 60 microcoulomb and the charge on the second capacitor is 120 microcoulomb, what is the total charge in the circuit? Or what is the charge supplied by the battery? Well, you can see the charge supplied by the battery when it comes to A, it will divide to Q1 in C1, Q2 in C2, so that the total charge Q is C1 plus C2. So the total charge is 180 microcoulomb that is delivered by the battery.